All right, open up your book to section 5-4. We're on page 261 in your book. The title of this section is the values of the 6 trig functions. Our objective here is to be able to find the value of the 6 trig functions approximately by using a calculator for any angle and exactly for certain special angles. And so we were introduced to the 6 trig functions in the first half of this. We even used the calculator to approximate some of these. And now we're going to focus on the special angles that it's referring to, be able to evaluate our trig functions exactly. All right, so we have 2 special triangles that you need to know. And these might be triangles you recall from a previous course of geometry. They might not be, but that's all right. These are 2 triangles that we need to commit to memory if you don't already have them committed to memory. We have a 30, 60, 90 triangle. 30, 60, 90 is describing the measure of your angles. So you have a 30-degree angle, a 60-degree angle, and a 90-degree angle on this first right triangle. And then the second one is a 45, 45, 90 triangle. That's a 45-degree angle, another 45-degree angle, and a 90-degree angle. So that second triangle there is actually an isosceles right triangle is what you end up with. So the 2 triangles here, these are the side lengths that we can put on our 2 triangles, and that's in particular what you need to know. It turns out that on that 30, 60, 90 triangle, you have side lengths of 1, 2, and root 3. In fact, that's kind of a nice way to remember this one, is it's 1, 2, and 3, or root 3 really, but pretty close to just 1, 2, and 3. And then the smallest side is opposite the smallest angle. So opposite the 30 degrees is the 1. And then opposite the 60-degree angle turns out to be root 3, and the hypotenuse turns out to be the 2. You can use Pythagorean theorem there. Once you know 2 of these sides, you can come up with the third one there, which is where the root 3 actually comes from. Over there on the 45, 45, 90 triangle, this has side lengths of 1, 1, and root 2. So the side opposite your smallest angle, which in this case is 45, you have 2 45-degree angles, is again the 1. And the hypotenuse then with Pythagorean theorem would give us the square root of 2. So again, some similarities there to help you remember this. One thing that you might do is look at the smallest side. Notice that the smallest side on both triangles is 1. That's one thing you can use to help yourself remember these. And notice that the hypotenuse in both of these triangles involves a 2. In one case it's actually 2, in the other case it's root 2. But in both cases here we have 2 that's on the hypotenuse. And then for the 30, 60, 90 triangle, just realize that you have to have a third side that's going to be different because you got 3 different angles. And so if I already know that I got sides of 1 and 2, that should help you remember if 3 is going to be on that third side, or it's really the square root of 3. But those are some hints to help you remember those. But those are 2 things you need to commit to memory, and you need to commit them to memory immediately. Those are 2 triangles we will use over and over and over again. All right, a little recollection here, something that we saw in the previous section there. Actually, we did a example that illustrated this in the previous section. That we calculated the reference angle for a given angle, and then we actually used cosine. That when we took the cosine of theta and compared it to the cosine of the reference angle being that it's positive and acute, means that it's in the first quadrant if we were to sketch it in standard position, and we know all of our triangles, or sorry, all of our angles in the first quadrant will end up giving us trig functions that are always positive. That's what the all part of this represents, that all 3 of your trig functions are positive in that first quadrant when you deal with angles that fall in the first quadrant. So it turns out that if you take the absolute value of your trig function for the given angle you're working with, that will turn out to be positive, and the sine of the reference angle is also positive. But not only that, but those 2 will equal each other. Not only will they have the same sine SIGN, but it'll also end up giving you the same trig value as well. Which gives you kind of an interesting way then you could think about solving some problems there that involve some nice angles, or breaking a problem down into reference angles. That instead of dealing with the angle they've given you, theta, you could think about that in terms of the reference angle, the sine of theta sub r. Of course, the other part of that you have to worry about then is what's the correct sign, SIGN, of your number. Is it supposed to be positive or negative? And if we remember our little acronym over here on the right that all students take calculus, the ASTC, I can use that to help me remember what the sine, SIGN, of my trig function should be. You know, if I'm talking about an angle that's in the fourth quadrant, for example, and I'm finding the cosine of it, I know that the cosine function is positive down there, so therefore it's going to give me the exact same value if I just took the cosine of the reference angle. Versus if I was back in the second or third quadrant, cosine's negative in those two, so I'll get the opposite value that I want. So in other words, using these two kind of in conjunction here, I can evaluate a trig function at any given value of theta, but use the reference angle instead to do it. All right, that's what that, the sketch there of the four quadrants, that along with this property there between the absolute value of your trig function and the trig function evaluated at the reference angle. Those two in conjunction tell me that. One thing to note over there, you'll notice that we didn't mention anything about your secant, cosecant, and cotangent here, and that's because if you reciprocate a number, you get the sign stays the same. So your reciprocal functions will have the exact same sign, SIGN, as your sine, cosine, and tangent functions do. So what that means is, as it says here, so for any angle theta, the reference angle theta sub r can be used to evaluate the six trig functions there. It's the reference angle along with knowing the plus or minus sign that should go out in front of each of those numbers there based on our four quadrants. All right, let's take a look at a couple of examples here then. Look at example 3. Example 3 says to find exact values, that is no decimals, of the six trig functions of 300 degrees. All right, I'm going to start out by calling theta the 300 degrees. Sometimes that's nice to do in your problem just so you don't have to keep writing down 300 degrees, especially when they're going to ask me to find all six of these values here. All right, so let's start out by sketching this angle theta. And you don't always have to sketch the angle, but sometimes that's nice to do. Sketch the angle theta. Well, 300 degrees falls in the fourth quadrant. 300 degrees is going to be somewhere around here, we'll say. And I'll mark that angle there as theta. This is theta. And now if you sketch in your reference triangle here, we're going to try to eventually get away from having to sketch in the reference triangle every time, but I think to start off with, this is going to be a little bit easier if we sketch that in there. So I'd have a triangle that looks something like this. And in particular, find the reference angle is really what I need to do. So if my angle theta is equal to 300 degrees, then my reference angle theta sub r is going to be equal to 360 minus that angle theta, which is 300 degrees. So the reference angle turns out to be 60 degrees. So that's this angle right here. My reference angle is 60 degrees. Well, that's one of the three angles of that 30, 60, 90 triangle. So I know something about these side lengths here of this little triangle that I've sketched in here. The adjacent side of the horizontal leg of this must be equal to 1. That's the shortest leg because that's going to be opposite this 30-degree angle down here. The vertical leg of this triangle, again, this is my right triangle right there. That's my right angle. The vertical side of this is going to be equal to the square root of 3. And the hypotenuse turns out to be 2. Okay? Now, what you really need to do is you need to write down what u and v and r are equal to. That I want to convert these sides of this triangle over to some point. And in particular, I want to look at that point right there that's at that vertex there on that 30-degree angle. That is, I want to look at the point that falls on my terminal side of this angle and name it. Well, I can use this horizontal leg to help me name that. That's in the fourth quadrant. That's going to be a positive 1. And then I can use this vertical leg to help me name the corresponding y value, the value for v. But since it's in the fourth quadrant, that's going to be a negative value. So this is a negative root 3. Again, we're going to eventually try to get ourselves away from having to draw in this reference triangle every time. We're going to start out with it here, but the key is you always want to be able to write this as an ordered pair here, UV. All right. Now, the reason for doing that is because notice I'll get the right signs, positives or negatives, that'll show up in here. And of course, the R value is already calculated here. It's already there, so I don't need to write it down again. That's the value of 2. It's always on the distance from your origin to your ordered pair there, UV, and it's always a positive value. All right. So now with that, we can calculate our 6 trig functions. I'll do that down below here. Maybe I'll even be more specific here and write down what I know about u, v, and r, just so we're clear here. I'm saying that u is equal to 1, v is equal to the square root of, negative square root of 3, and r is equal to 2. That's our u, v, and r. That's what we're going to use to find our 6 trig functions. So let's start out with sine. Sine of 300 degrees, or I'm going to write it as sine of theta here, since I define theta as the 300 degrees. Sine is equal to v over r, so that's a negative root 3 over 2. Cosine of theta is defined as u over r, that's 1/2. And finally, the tangent of theta is defined as v over u, so that's a negative root 3 over 1. I'm going to write it that way, and I'm going to leave it that way. So it'll make it a little bit easier, perhaps, to do the reciprocal part of this, which is what we need to do next. So now, for the reciprocals, the reciprocal of sine is the cosecant of theta. And since it's a reciprocal, just take that quotient there and flip it over there. We end up with 2 over the negative square root of 3. And then for secant, secant is the reciprocal of cosine, so that's going to be 2 over 1. Again, if you want to simplify that after you write it down, that's fine, but I'd like to see it written in that quotient form first. And then finally, the reciprocal of tangent is the cotangent of theta. And flip that over, you end up with 1 over the negative square root of 3. There's our 6 trig functions evaluated at 300 degrees. And those are the exact values. That's what we're looking for. All right, take a look at example 4. Example 4 says, without a calculator, evaluate the 6 trig functions for the angle of 180 degrees. So we're going to call that theta. Theta is equal to 180 degrees. So again, I'm going to start out with a sketch of this. You, again, don't have to sketch it, but sometimes, especially for starting out here, it might make it easier if we start out with a sketch here. So 180 degrees, well, that would be this angle right here. We'll call that theta. So I should have done that in a different color here. I guess we'll just mark it then. It's not one to get rid of it. So we'll call this theta. And we're going to run into a problem here because I can't draw in my reference triangle. Because of the fact that my terminal side ends up being one of my axes here, there's no reference angle to sketch. This is exactly why we want to get away from sketching reference triangles if we can. Because we run into problems like this. But I can always write this in terms of u, v, and r. All we got to do is come up with a point that lands right here. So that's the negative x-axis. So that would be, for example, negative 1, 0. We can do that. And you can pick any point that falls along the negative x-axis. Negative 2, 0, negative 3, 0. Pick any point you want. It'll work. Your r value will change depending on what point you pick, but generally we pick the one that would fall in the unit circle, so that's why we're picking negative 1, 0. And now to calculate r is just simply the square root of u squared, that's a negative 1 squared, plus v squared, that's 0 squared, so that's the square root of 1, that's just 1, which should make sense that, this distance that you are from the origin, right here, if we're at the point negative 1, 0, that distance is 1 unit. Should make sense that that is exactly what that's measuring there for us, that value of r. All right, so now I've got u, I've got v, and I've got r, and I guess just to make sure we're clear on what we have here, I've got r is written down. Let's write down what u equals. U is equal to negative 1, and v is equal to 0. Ooh, that could cause some problems. Because some of these properties I got to write down, or some of these trig functions I write down, have v in the denominator. So let's be careful as we write these down. Then let's start with the 3 trig functions that we know, and then we'll deal with the reciprocals. So we've got the sine of theta, or the sine of 180 degrees. Again, if you have not defined your trig functions, if you have not defined your angle theta, then you have to write your 180 degrees down over and over again. All right, so sine, cosine, and tangent. So sine of theta we know is equal to v over r. So that's 0 over 1, or obviously that's 0. Cosine of theta is equal to u over r. So that's a negative 1 divided by 1, or that's a negative 1. And finally, tangent of theta is v over u. So that's 0 divided by a negative 1, or that's just 0. All right. Those we didn't have any problem with. Let's reciprocate those now, which is where we're going to run into a few issues here. If we take the cosecant of theta is the reciprocal of sine, which means that we're going to get 1 over 0. This does not exist. This is undefined, because of the fact that you'd have 1 divided by 0. What about the reciprocal of cosine? That's secant of theta. And so the reciprocal of that would be 1 over a negative 1. And that turns out to be the same thing, negative 1. And if I take the tangent of theta, the cotangent, I already got the tangent of theta. I want the reciprocal. So the cotangent of theta, and that's where I run into a problem again. I'll get negative 1 over 0. This does not exist, or it's undefined. Okay. All right, that's the end of the second half here of section 5-4.